Next topic is the oxidation state. Oxidation state of d block elements or transition element is completely different from that of representative elements, means S block or P block elements. If we take the example of any of the group of P block, like if I am taking the example of group 13, the group oxidation number of this group is +3, which is 10 less than that of group number. But as we move down the group, the oxidation state becomes +1. Means all these elements can exhibit two types of oxidation state, +1 and +3. Out of these two, +3 is more stable for lighter element, whereas +1 is more stable for heavier element. Moreover, we can see one more thing: the change in oxidation number occur by 2, means it becomes +3 to +1. But if we take the example of any of the metal or any of the group of transition element or d block, then change in oxidation number occur by 1. For example, if we see the different oxidation number possible for the manganese, it is +2, +3, +4, +5, +6 and +7. Here you can easily see the differences. Here change in oxidation number occurs by 2, but here change in oxidation number occurs by 1. This is one of the main difference between transition elements and representative elements. One more difference is there. If I am taking the example of group 6, where the elements are chromium, molybdenum and tungsten. All these elements can exhibit +6 oxidation number, but out of these three, +6 is more stable for tungsten. Clear? So here we have seen lighter element can exhibit higher oxidation number, means higher oxidation number is stabilized by the lighter element. But here higher oxidation number is stabilized by the heavier element. These are the two main differences between transition elements and representative elements or P block elements. Clear? I repeat once again, the one main difference is change in oxidation number occur by 2 here change in oxidation number occur by 1. Here lighter element stabilize higher oxidation number, here heavier element stabilize higher oxidation number. These are the main differences. Now the question arises, why these elements can exhibit large number of oxidation state, why these elements exhibit variable oxidation state. So reason lies in the electronic configuration. As we know, in D subshell, total 10 electrons can come, and these are filled progressively one by one. So till middle of the series, unpaired electron increases, and after midway, pairing of electron starts, means number of unpaired electron decreases after midway. So I am taking the example of 3D series where elements are scandium, titanium, vanadium, manganese, iron, cobalt, nickel, copper and zinc. Clear? Here first element is scandium, can exhibit +3 oxidation state. This is the only element in transition series which cannot exhibit variable oxidation number, means more than one kind of oxidation state. But other than this, all the transition element can exhibit various oxidation state, more than one oxidation state. A maximum oxidation number is exhibited by manganese, which is +2, +3, +4, +5, +6 and +7. This element can exhibit large number of oxidation state, or we can say maximum number of oxidation state among 3D elements, because it has maximum number of unpaired electrons. In unpaired electron increases till middle of the series, as we have discussed earlier. Then the tendency to exhibit more and more oxidation state increases till middle of the series, +3, +4, +5, +6. Here it can show only +2, +3, +4, +5. Here it can show +2, +3, +4. So here we can see easily change in oxidation number occurs by 1, and it is more and more till middle of the series. After midway, it is decreases again because number of unpaired electron decreases because pairing starts. So it is +2, +3, +4, +5, +6, is the most common oxidation state in this series. Other than scandium, all the elements can exhibit +2 oxidation state. So if question comes, which is the most common oxidation state which is exhibited by all the elements or most of the elements of transition metals, then answer would be +2. +2 is the most common oxidation state. These are some important discussion related to oxidation state. Other than this, I would like to tell you one more important thing. The zero oxidation state is exhibited by the element only when it is present in the free state. Suppose oxidation state of iron is 0 only when it is present in the free state. It is not present in the compound. As it will form the compound, its oxidation state becomes positive because this is the electropositive metal. This happens with all the elements of transition elements because they are electropositive. They can lose the electron easily, so they exhibit positive oxidation number. Zero oxidation number is not possible in compounds. It is possible only when it is present in the free form. But one exceptional case is there. Whenever any metal form a compound with certain kind of ligands, which is pi electron acceptor, then oxidation number may be 0 also. For example, in case of tetracarbonyl nickel, oxidation number of nickel is 0. In case of pentacarbonyl iron, oxidation number of iron is 0. Although these elements nickel and iron are present in the compound, but even that their oxidation number is 0 because they are pi electron acceptor. Means two types of bonding are here. One is between the bonding is between metal and ligand. This is the ligand means electron donor. So by donation of electron from ligand to metal atom, sigma bond is formed, which is a comparatively stronger bond. And at the same time, those electrons which are present in metal as a paired electron, d electrons, they donate the electrons in bond, pi bond will form. So these two type of bonding is collectively known as synergic bonding. So whenever metal forms synergic bonding with certain kind of compounds like carbonyls, then its oxidation state is 0. This is also one of the very important fact. So this is all about oxidation states of transition elements or d log elements.